For the first section, we're really just going to cover some angles and some of the basic measurements of degrees and radians and when you would use one over the other. So here is an angle, and your initial side's always on the positive x-axis. That's where we always begin measuring. And we always move in this direction. We go counterclockwise. And the place where we end, we call that the terminal side. So initial side and terminal side. That's the language you'll see in the book. And just to kind of illustrate this, we use this one a lot throughout the year, but here's a Desmos illustration. As we go throughout the unit, this will become more clear as to why you start at the positive x-axis and why you go counterclockwise. But trust me, everything's set up mathematically the way it's supposed to be, and when I hit play here, you see that your angle started at the positive x-axis, and it's definitely going counterclockwise around. And that's also making a triangle because everything that we do with these angles, you can turn into a triangle, put on the unit circle, and do some other stuff. So hopefully it kind of rings some bells from geometry and a little bit of algebra too. But those are some of the basic terminology things we'll talk about. One of the biggest adjustments I've found is getting used to radian measure. Usually at this point, degrees are you're pretty comfortable with those. Radians you have some experience with usually at this point, but it's not as comfortable as degrees. So that's one of the big things I want to help you just get comfortable with radians. And I usually would illustrate a point with a piece of paper and a circle in the room, but this will be good enough, I think. So I'm going to try to illustrate this point of where pi comes from and what a radian truly is. And it says a radian is a radius stretched around the edge of a circle. So what I'm going to do is take my compass and set it so it's as big as the radius of the circle. And then I'm going to just kind of move it out to the edge. And I'm just going to make some arcs. And we'll go around the whole circle like that. And I'll come back when I get all this completed. We'll talk about the result. So I just completed my last one. So what I've done here, again, I took the radius of the circle and stretched that length out across the edge of the circle. And we got a 1, 2, 3, 4, 5, 6, and then there's a little bit more that I left over. So what it turns out is that if you stretch the radius around the circumference of a circle, it goes about 6.28 times. And we call that tau in math. It's a Greek letter. You're probably more familiar with half of that term, which is pi, which is about 3.14. And of course, that's a never-ending decimal. It's one of those, we call them transcendental numbers in math. They're these enigmas where they're the ratio of one thing to another. It's the ratio of the circumference divided by the radius, or a diameter for pi, yet it produces this irrational number. So it's a paradox. You're creating a ratio, this number divided by this number, and it creates an irrational result. You saw one with E earlier as well. So there's a lot of these transcendental numbers. They're enigmas. We don't fully understand how they work, to be honest. A lot of people have tried and haven't quite figured that out. But that's why that works. It's just kind of a natural result. If you stretch the radius around the edge of a circle, it goes about 6.28 times. So there are about 6.28 radians in one lap around the circle. So usually we'll just, instead of saying tau, we usually say 2 pi. But some people like to use that letter tau. So how many radians are in a circle? I guess I should answer that. You have 2 pi radians in a circle, which is equal to 360 degrees. That's going to bring us to the next piece, and that's converting. So if I want to convert degrees to radians, so if you've done this in chemistry, it kind of helps, I think, set up these little conversion tables. The easiest way I've found, and science really helped me with this stuff, converting one unit to another, is just if you've got a symbol you want to get rid of, or a unit you want to get rid of, make sure that's on the bottom. So 360 degrees, that's what I wanted to get rid of. And there's 2 pi radians per 360 degrees, so that part will divide out. And we will get about 300 pi over 360, and you always want to reduce, so both can be divided by 60, so 5 pi over 6. An easier way to go about this is that there's 2 pi radians for 360 degrees. You could divide, and pi is really a half a circle, so pi radians has 180 degrees. You could have used pi and 180 here, and that would get you there a little bit quicker. 150 over 18, or 15 over 18 is 5 over 6, and it's still pi, so same result, just maybe a little bit quicker way to get there. Since this is already a fraction, probably the easiest thing to do is just multiply it by a fraction. And if we want pi to go away, we can put it on the bottom. There are 180 degrees per pi radians. So the pi's would actually divide out. 180 divided by 6 is 30 degrees. Right, coterminal angles, that's when you have an angle that ends in the same place as another one, but has a different measure. Now that's not going to make a lot of sense with degrees, I'll be honest. Degrees are really good when you have stationary objects and you want to know the angle between them. So let's say these are 2 different points on the ground or something. Or maybe there's 3 different points here. We're making a triangle out of them. And this is the angle between these 2 points. So degrees is really good for that. Radians is really useful when things are rotating. And we're going to start getting into a lot of physics applications throughout these units with rotating objects and places where radians are really good. But that's usually when things are moving, you want to go with radians. If things are sitting still, degrees is typically the way to go. We're going to practice both for now, just so you get used to both. But that's typically how this is going to go. So coterminal angle. I want to know another angle that also ends right here. Well, the easiest way to do that is just to go another ladder. If I went another 360 degrees, then that would put me at 465. So that's an angle that is also coterminal with what I started with here. The other thing to try would be to go the other direction. So if going positive direction, or if I go counterclockwise, that's a positive angle. If I go clockwise, that's a negative angle. And usually it's easiest, I think, just to kind of picture what you've got here. You've got a full circle minus the 105 degree part. So 360 minus 105. So that would be 255 degrees. Now keep in mind you went clockwise, so it's actually going to be a negative angle. And that's what it asks for. Give one negative, one positive coterminal angle. So a positive is 465, a negative is negative 255. And you could make additional laps as well. And these are the most common 2 answers you would probably want to give. Let's do the exact same thing in radians this time. And this is probably a little more common because with rotation, you might rotate an extra time, and that's where these coterminal angles really get used the most. So let's say I'm starting positive x-axis with 4 pi over 3 radians. So let's say I went a full circle extra. Well, so a full circle is 2 pi radians. So I can put that over 1 if I need to. I can scale it up by multiplying both top and bottom by 3. So that would give me 10 pi over 3 as another coterminal angle. Now if I went the opposite direction, again, I went counterclockwise for this angle I'm given. So what if I went the opposite way? What if I went clockwise? Well, again, think of it as a whole circle here. The whole thing is 2 pi radians. But I'm subtracting off 4 pi over 3 to see what's left down here. So let's do that math and see what happens. So if I want this over 3, again, it'd be 6 pi over 3. So that'd be 2 pi over 3. Also keep in mind that's negative because I'm going in the negative direction. I'm going clockwise. So negative 2 pi over 3 would be another coterminal angle. Last thing for today is complements and supplements. Just remember, complements add up to 90 degrees or pi over 2 radians. Supplements add up to 180 degrees or pi radians. So that's when you have 2 angles together. If 2 angles add up to 90 degrees or pi over 2 radians, they're complements. If they add to 180 or pi radians, they are supplements of each other.